In this lesson, we're going to talk about transforming domains and ranges. Suppose we know the domain and range of a random function without knowing what the function looks like. We can determine the domain and range of that function after a series of transformations. The process involves putting the values of the original domain and range through the mapping formula. Recall that the mapping formula says xy maps onto x over k plus d, comma, ay plus c. If we focus on just the left side of each coordinate pair, we get x maps onto x over k plus d. And if we just focus on the right side of each coordinate pair, we get y maps onto ay plus c. Our job will be to put every domain value through x maps onto x over k plus d and every range value through y maps onto ay plus c. Now, before we go any further, let's take a look at a rule involving inequalities. We'll bring the discussion back to domain and range shortly, and you'll see how this is relevant. We know that 1 is less than 2. Now, in terms of a number line, what that means is that 1 is to the left of 2. Now, if we were to multiply both sides of this inequality by -1, we'd get -1 is less than -2, like it says here. But we know that's not true, because if we continue this, if we continue that same number line, we see that -1 is not to the left of -2. So unlike equations, we cannot just multiply or divide both sides of an inequality by a negative value. We need to change the direction of the inequality operator. In other words, we need to change less than to greater than or vice versa, or change less than or equal to greater than or equal to, or vice versa. This leads us to a general rule. Whenever we multiply or divide both sides of an inequality by a negative value, we have to switch the direction of the inequality operator. For instance, 3 is less than 4, but if we multiply both sides by -2, we get -6 is greater than -8. 15 is greater than -3, but if we multiply both sides by, but if we divide both sides by -5, we get -5 is less than 1. So now back to our discussion of domains and ranges. Suppose the domain and range of a function f are given by the domain and range shown. We want to determine the domain and range of this transformed function. Okay. So what we're going to do is we're going to first of all determine the values of a, k, d, and c using our standard manipulations, algebraic manipulations of the original expression. A is 5, k is 2, d is 9, c is 3. Now let's focus on the domain. The two values that appear in the domain of f are -4 and 10. There are an infinite number of values in the domain, but these are the two that we can visibly see. They're the they're the boundary points of intervals for the domain. Now you might be tempted to say, sir, -4 is not actually in the domain because it just says x is less than -4. And if that's what you're thinking, good for you for thinking it. But we're allowed to put -4 through because we're dealing with all the real numbers up to -4, and it's acting as like a barrier, as a limit. So we're able to put it through for the rest of this question to help us answer it. So we're going to put -4 and 10 through the portion of the mapping formula that says x is greater than x over k plus d. So if we let x be -4, we know k is 2, d is 9. And we get -4 maps onto 7. And if we let x be 10, then 10 maps on to 10 over k plus d, 10 maps onto 14. So now what we can do is instead of saying x is less than -4, we can say x is less than 7. And instead of saying x is greater than or equal to 10, we can say x is greater than or equal to 14. Now you might say, well, sir, is this one of those situations where we need to switch the direction of the inequality operator? And the answer is no. The only thing we multiplied or divided by was we divided by that +2. We don't have to change the direction of anything. So our transformed domain is shown below. Now let's look at the range. The two values that appear in the range, obviously there's an infinite number of values in the range, but the two that act as boundaries of intervals are -1 and 14. We're going to put those values through the portion of the mapping formula that says y maps onto ay plus c. So -1 maps onto ay plus c, 5 times -1 plus 3, and 14, if we let y be 14, it maps onto 5 times 14 plus 3, in other words, ay plus c. It maps onto 73. Now, that means the -1 mapped onto -2, and the 14 mapped onto 73. Can we just write out the range like this without changing the direction of the inequality operators? The answer is yes. The reason we can is the only multiplication we did to the original value was we multiplied by 5, and there was no division. So we were multiplying by 5. Since 5 is a positive number, we don't have to change the direction of any inequalities. And we can say that our range is -2 less than y less than or equal to 73. Now, suppose the domain and range of a function are given as shown, and we want to know the domain and range of y equals -3f of x plus 6 plus 4. Well, we can see from this transformed function that our a is -3, our k is 1, our d is -6, and our c is 4. Focusing on the domain, we're going to take this -5 and this 3, and we're going to put those through the part of the mapping formula that says x maps onto x over k plus d, because those are values in the domain. So -5 maps onto -5 over k plus d, and 3 maps onto 3 over k plus d. Did we ever multiply or divide by a negative? The answer is no. We divided by 1. I've seen students say, but wait a second, sir, we subtracted 6. That's a negative. It doesn't matter if you add or subtract in terms of changing the direction of the inequality operators. It only matters if you multiply or divide by a negative value. The only thing we divided by was 1. No changing of the inequality operators here. So we can just sub in for -5 a -11, and we can sub in for 3 a -3, and there's our new domain. Now, finally, we're going to do some changing of inequality operators right here. The two values that we see in the domain when we write it out in set notation form are 1 and 6. We're going to put those through the portion of the mapping formula that says y maps onto ay plus c. So 1 maps onto -3 times 1 plus 4, which actually is 1. So interestingly enough, 1 maps onto 1. 6 maps onto -3 times 6 plus 4, which is -14. Okay, so based on what we've done so far, you might be tempted to say, okay, y is less than or equal to 1, or y is greater than -14, because 1 mapped onto 1, and 6 mapped onto -14. But that would be wrong. The reason it would be wrong is we need to switch the direction of the inequalities. And the reason we need to do that is in these calculations, we were multiplying by a negative. We were multiplying by -3 both times. So therefore, we need to change the direction of the inequalities. Instead of putting instead of putting greater than -14, we need to put less than. Instead of saying less than -1, we need less than or equal to -1, we need to say greater than or equal to -1. Okay? But we just as a final little piece in terms of like mathematical courtesy, instead of wording it like this, we like to put the smaller numbers first. So instead of saying y greater than or equal to -1 and then making the person go back to y less than -14, it's kind of courteous to say in order from least to greatest. And what if the domain and range of the function are given as shown, and we want to know the domain and range of y equals 9f of -7 bracket x minus 16 plus 4? If that happens, we know that a is 9, k is -7, d is positive 16, and c is 4. Okay? So focusing on the domain, we see that we're going to be putting the values of -7 and 14 through the transformation mapping formula. Now, since k is negative, we're dividing that -7 by -7, and we're dividing that 14 by -7. That means that we're going to have to change the direction of the inequality. Well, -7 mapped onto 17, and 14 mapped onto 14, interestingly enough. But we have to change the direction of the inequalities, so we need to change that less than or equal to sign to a greater than or equal to sign, and we need to change this less than sign to a greater than sign. So this is our new domain. But we like to state the smaller numbers first, so we say 14 less than x less than or equal to 17. And that is our domain. And our range is relatively straightforward. We're going to take y values of -3 and 20 and put them through the mapping formula. -3 maps on to a times -3 plus 4, which is -23, and 20 maps on to a times 20 plus d, which plus c, sorry, which is 184. Now, since we were only multiplying by 9, that means we did not have to change the direction of the inequalities, and so we can simply sub -23 in for -3 and 184 in for 20. And when we do that, it gives us our transformed range. So, as a little memorizing thing, in this type of question, we determine the values of a, k, d, and c. Then we put those domain values through the formula x maps onto x over k plus d. If we multiply or divide by a negative number, in other words, if k is negative, then we switch the directions of the inequality operators in the domain. So if k is negative, switch operators in domain. And then we could look at the range, and a similar thing takes place. We put those range values through the formula y maps onto ay plus c. Well, if we multiply or divide by a negative number, in other words, if a is negative, we switch the direction of the inequality operators in the range. In other words, if a is negative, switch operators in the range. And if you can read that handwriting, you're pretty good. That's this lesson. Hope you enjoyed it.